Hello, everyone. Today we will be learning about decimals. It's just a little summary about what you will be learning. Everything really about decimals, the definition, its uses, its explanation, um, really just some first hands-on knowledge with decimals. If you haven't seen it already, some of you may be familiar with it already. Skills acquired will be gaining new math principles, connecting knowledge from fractions or percentages to decimals. I talked heavily in my other video about ratios, about a lot of percentages and decimals and fractions as well. But this is more in depth about decimals and some word problems as well. So let's get started. Let's dive right into it. So what are decimals? Decimals are numbers expressed in a scale of tenths, right? And that may be confusing at first, but it's just important to just remember it's a scale of tens, right? Uh, and even if you've had heard of decimals, you may have not heard of this uh, definition, but it'll make a lot of sense in 1 second, right? Just a little picture decimals, we got this, right? It will seem intimidating at first. This is a very big math concept, and this presentation won't be able to cover it all. I'll try to cover most of the bases, but please, there are websites that I include at the end, my sites I use. Go look at that. Go look at some of the games and videos that I'll point out during the presentation that will definitely help you. Um, so let's just start, right? And at the top, you can see a little interactive game and videos, right? That's just one of them. So the basics of decimals, right? With decimals, they normally represent a whole number plus a fraction. Right? And a decimal is the same as a fraction, right? You've probably seen 1/2 equaling zero point 0.5, and not really understanding so much the zero point 0.5, but just understanding it's like half of one. Um, maybe you've heard of 0.33 repeated, things like that. 0.25, a fourth. Um, but just to understand what that decimal point is, it's a point. It's a dot, really. If we want to just simplify it, it's just a dot to represent the whole number from the fractional number, right? What that means is that the left-hand side of that dot, that point, is the whole number. 1.5. One is that whole number. We have a whole thing of something plus another half. That the right-hand side, that 5 represents that we have half of one, right? And this is what I was saying about the scale of tens, right? Let's say we have a 100.00, right? Divide, these are the number of places: 100, tens, ones, tenths, hundreds. It goes sort of, if from that decimal point, it sort of goes in reverse, sort of both going in the left and right directions, except it's very important to understand that with whole numbers, it starts with ones, tens, hundredths, thousands, 10,000, so on, right? For fractions, it starts at tenths, hundredths, right? And that's why I have that 1/10 and the 100th to symbolize it's 1/10, right? If we have 0.1, that's the equivalent of saying 1/10. But if we have 0.01, that's the equivalent of saying 1/100, right? And I'll show you some blocks. This will make a lot more sense, right? I'm saying this all this information right at you. It can be confusing, but what it is, it's we have there's, from the hundredths place to get to our whole number, it's 100. We would need 100 blocks. And I'll understand like that block concept in a second. But just right, we want to understand the part of the number, like I was saying. the whole numbers to the left, decimal point fractional part. So, right, that the 0.16, right? Let's just move the 258 to the side. 0.16 is the same as saying 16 over 100, right? If we go to that last decimal point and we know it's the hundredths place, we can just do 16 over 100. So that's the same thing as saying 258 and 16 and a hundredths, right? Or 16 over 100. Or we can even simplify that the number, if well, you honestly really can't simplify it. You can simplify that fraction, but when dealing with that decimal, you can't really simplify it because those decimals can't be simplified in that number, right? We would need to be simplifying it towards some common goal. So, right, and this is the decimal place values. It's very important that you understand the distinction, right? Tons and tons of students will get confused with that first decimal point. Right, understanding the left of it is ones and the right of the decimal point is tenths. It's extremely, extremely important to understand that. Right, that we start on the right hand side, right? I'm assuming you understand the left hand side much better, and that right hand side is very new and familiar. So looking at that right hand side, it can be intimidating, right? Tenths, hundred, thousands, 10,000s. And it'll make sense more as we keep going, but just to show you and understand, just so you can understand, right? That 0 is in the place of the tenths, the 3 is in the place of the hundreds, the 2 is in the place of the thousands, and the 4 is in the place of the 10,000s. It's very important that you sort of just, there isn't really a trick. You just have to memorize it. And if you understand that the decimal, right, what the power of tens, right, you want to know what that is. Well, if we start with the 10th, multiply 10 by 10, it's a hundredth. It's the hundredth place. Multiply 100 by 10, it's the thousands place. Multiply 10 by 1,000, it's the 10,000s place, and so on. That's why the power of 10 becomes so important, right? Because when that number goes over 10, you move it over 1, right? So if you sort of, to just explain that, the 3 in the hundredth place, right? If we add 7 to that point, I mean, if we add 0.07, excuse me, 0.07 to that becomes 0.1, and that becomes then the tenths place. So this is sort of the block method I was telling you about. This is how I first learned it when I was younger. I still sort of honestly do visually think of these blocks. I'd suggest, if we were in school in class, your teacher would probably, hand out some, Lego blocks that you can connect and, take apart, just to visually see it a little bit better. But right, let's take the number 17.48, and I really do like this picture because it does visually describe it very well. So the 17 is the whole number part, right? We know that 17 whole blocks, right? Let's say this is describing some block. Well, now we have the 0.48, okay? And that's what we have to, analyze right now. So we have, for the first place, it's the 10th place. So that means there's 10 little rectangles, blocks, however you want to see it. And we have 4 of them. So we shaded right here 4 rectangles. 4 of the 10 rectangles are shaded. So that represents the 0.4. Now it's the 0.08 that we have to represent. Now we have 8 blocks of 100, right? These 8 blocks, if I was going to do, a whole row, that would be equal to 0.1, right? It's 0.08 though, so it's 8 of the 10 blocks in that row, right? A whole column would be equal to 0.1. So really what we did is we just made this tenths into hundredths, right? 10 hundredths. Very important. And they say 4 out of 10 and 8 out of 100. If you want to say it like that, say it like that. Both are acceptable. You know, both however you visually want to see it that way. Right? And these block method, it's so crucial that you understand it from the start. That it's if we had, I wish you could sort of see me, but just to visually, just mentally see it, you know, if we have, you know, all these different colored balls or, you know, anything, and we're just slicing it and slicing it and slicing it by multiples of 10 or multiplying it by 10. Either way, it's, you know, it's these, you know, on the left hand side, these whole blocks were then split into tenths, and then each of those rectangles, right, were split into tenths. Or we can see the whole square getting split into tenths. So bigger versus smaller, right? And this is just another way of seeing it, because I just want to hound down on the point that the fact is that to the left it gets 10 times bigger, and to the right it gets 10 times smaller. And that, if you want to take one thing away from these decimals, it's understanding that. It's understanding that that 0.5 is 5/10. It's understanding that 0.09 is 900ths, and that 0.001 is 1,000th, and that whole thing combined is 591 over 1,000. And we will go over separating these decimals so you can get some good practice with them, so you can just understand them a little bit better. So, right, let's explain these decimals and these blocks, right? So important. Now, let's say this whole square is equal to 1, right? This whole square is equal to 1. Well, if we picked one square, just one tiny, tiny square, then that's 1. So 1 out of the 100 squares would be 0.01, right? Because tenths, hundredths, that 0.01 means 1 out of 100 are shaded. So let's see another one, right? Well, what's the difference? A whole column is shaded. A whole column is shaded. 10 squares. So right, we're saying, well, right, if you know, you can look at by rows or columns, because there's 10 rows, 10 columns, but we had shaded one column. Right, a whole column shaded, so that means that it's one of the 10 shaded. So it's 0.1, it's 1/10. Right, but it's actually the same as saying, right, if we want to count all the squares, right, we know that there's 100 squares, and if we want to count the columns or the rows, we know that there's 10. So it's the same as saying 10 hundredths. 10 hundredths is 0.10. But when you have zeros at the end of a fraction, or I mean at the end of a decimal, excuse me, you can just remove them, right? We're saying 0.10 is the same as saying 0.1. It's the same number. We can just knock off that 0, right? And you know what I will do, I will keep that 0 there sometimes to just to see that, you know, you might get confused, right? There's one there, but there's 10 squares. It's because that's in the 10th place, right? If we had that 0 there, we can make the same justification that there's 10 hundredths. So that's 1/10. So let's do it with a little bit bigger of a number. We have 3.95. Well, we have 3 whole squares shaded. Now we have to deal with the 0.95. Now, let's just go by columns, because that's what they did. They shaded 9 columns, right? They shaded 90 squares, because that's what that 9 means in the 10th spot. 10, it's 9/10, or 90 squares. But then we also have the 0.05, that 5 at the end of that 3.95. And what we have to do is then shade 5 extra squares. So we're only left with 5 squares, right? So that's 3.95. And it's so, so important that you can visually see that we have 3 whole squares plus 95 extra tiny squares, right? And all we have 395 shaded squares out of those 400 possible squares, right? You can work backwards also. There's 4 squares, each having 100, so there's 400 squares. And this number is 3.95, so we're saying 4.00. And you can just knock off 5 right there, and you get the same answer. You know, again, with this using this square rectangle method, the difference of 25 and 6/10, right? You can see 25.6 is just 6 rectangles. I actually do wish that they kept it in the squares, so you can see that it's 60 squares. But the rectangles serve as the same justification. You know, 0.6 or 6/10 or you know, 6/10, any way you want to see it. But let's say we want to do 0.06, right? 0.06 would be 6 squares shaded out of 100. So that's what they did. It is 6 squares out of 100. It's not even a full column length, right? And if we want to even go a step further and do 6 thousandths, well, that's we would have to then split each tiny one of those 100 squares into 10 squares, and then shade 6 of the 1,000. And that they just obviously did not do that because that's a little too complex and too detailed to really visually see that. It'd be a speck in the whole square, very hard to see, and that's why they did not do that. But that's what it'd be, right? We divide each square or rectangle by 10 when we keep going further and further to the right. And that's why it's so important to understand that decimal is just the power of 10, right? We're going back by 10, 100, thousands. Keep keep multiplying by 10 as we go further and further to the right. And these are some squares again, right? Look at the squares. Right. We can even, like, I really do suggest you maybe getting some Legos or getting just blocks and just, you know, seeing, right, if I wanted 1/10 and I have 10 blocks, then one of them needs to be shaded, right? Same goes for 7/10. I have 7 blocks that are, you know, let's say I have 10 blocks, right? And they're all white, but I want to shade 7 of them purple. then I will paint 7 blocks. And then you can see the difference between the 7 shaded purple blocks and the 3 white blocks. Same now goes for this 18 over 100. Um, right, 18 shaded blocks out of the whole 100, right? And that's what they're doing. A column, a row plus 8 in the next row. And I'll explain the 1,000ths in 1 second, but I just want to point out that to those right, they did 0.1, 0.7, 0.18, and that's what we want to hand on as those decimals, understanding that 0.1 is in the 10th spot, right? So that 1's in the 10th. So it's the same as 1/10. So we can, 10 would be all the blocks and the 1 is shaded, right? 0.7 is in the 10th. So what we're saying is 0.7 7 over 10, and we have 10 blocks and all shade 7 of them, right? 0.18 is a little different. Right now we have a number in the 100th, so we have to put 18 over 100, right? 100 spot, 100, see how, these numbers correspond, and we shade 18 of them. And then we have 57 over 1,000. Now that's very I won't say insignificant, but very tiny, very small. That's why they didn't do those squares. Because right, that's like it would be very small with 1,000. We would have 1,000 squares, and only 57 of them would be shaded. I don't suggest getting 1,000 blocks and shading all of them. But those simpler ones, the 10th spots, the 100th spots, the 100th would even be a little complex. But you can just get 10 objects of something and visually think. Start. You can start very simple. You can start with 0.5. Right, I have 0.5. Well, that's 5 out of 10. So 10 of my blocks need to be shaded, let's say orange, right? Or, point 9 is the same as saying 10 out of 100, and we want, to, move aside 9 of those objects. That's the same thing as what we are doing. Same concept goes for, the 100ths. The 100ths do get more complex. The further out you go from the decimal point, the further complex it will be, and the further smaller the number will be. That's why it becomes a little more complex. Right? You can see these blocks get 10 times smaller, and it can become very scary looking, but it's just remember the decimal spots and you'll be fine, right? 0.18 is the same as just 18 over 100, right? That 8 is in the 100 spot, so we can just put 100 on the bottom, and that number is 18. So we're doing 18 over 100, and we shade 18 of the 100 blocks. Those 1,000 do get complex, right? 124 over 1,000, right? That's 1.124, right? Because it's 1,000, it directly corresponds. We can just put the decimal point 3 places out, right? And that's just a little trick, right? 1/10, we can there's 1 0, right? And normally it'd be 1 point, that 1 dot, and we move the dot 1 to the left. 18 over 100, there's 2 zeros in the 100, so we move the decimal point over to the left 2, so that becomes 1.8. 124 over 1,000. 1,000 has 3 zeros, so we just want to move the decimal point over 3 spots, and that becomes very simple, right? You just do a little hump over 3 times, and you can see. Right, and this is it again, right? 1/4 1/2, and 3/4 are just common fractions that you probably know off the top of your head, really. Even if you don't know decimals, knowing that, a fourth of a dollar is a quarter, and that's 0.25, right? That's why a quarter is 25 cents. There are such things as half-dollar coins, right? 1/2, 0.5, they're worth 50 cents. And then 3/4 is 0.75. And I really do like this. They did what they, block method using the grid. They those black lines separate it now into each was a half, and then with both of them make it a fourth. So you can see, right, one whole thing would be a fourth. And in that are 25 shaded red squares, right? It's 0.25. So 0.25, 25, 0.25, that means there's 25 shaded out of 100, right? Now this has 0.5 shaded, an extra 25 shaded, 50 shaded in all. That's half of it, right? 0.5 is half of 10, right? 0.5 is half of 1. 1/2, you probably know, is half of something. So that's 50 squares. And then 3/4 is, another grid, another, that gets that third quadrant, getting 75 now squares shaded. And it's very important, maybe just if you visually want to just keep looking at it, maybe pause the video for a minute and just see, if you even want to, like visually just counting those red squares can help, 25 squares, maybe you want to go look up line, a grid and start practicing that, shade those squares or whatever. It is very important just to understand that it's, a grid, a fourth, a half, a 3/4, just common fractions that you should know off the top of your head, visually be able just to see them. And this is also a good picture. These both are equivalent, right? They may not look at first, right? Especially because of all the squares. But let's just look at the figure on the left. Start very simple. There are 10 rectangles there. 6 are shaded. So that's 6 out of 10, right? 6/10 is equal to 0.6, right? We're moving that, there's, that 10 has 1 0. We're moving that decimal point 1 over to the left. And that's how we get that 0.6. And right, so now let's look at the right hand one. That left hand was easy, right? But the right hand is actually very easy also. We can see, you could count each square and see that there's 60 squares shaded. Or you can see that there's 6 columns shaded, and there's 10 columns in all. So, right, that's 6/10, and that's the same as 0.6. But what they did at the bottom is what I like. They did 60 100ths. 60 over 100, right? There's 100 squares in all, and there's 60 of them shaded. Well, we can simplify that fraction first and say that's 6/10, and you can just see, move the decimal point over to the left 1. Or we can just stick with the 60 over 100, and that becomes 0.60, and we knock off that 0 is what they did at the end, right? Because 100 has 2 zeros in it. Move the decimal point over 2 places. Very important, right? That we didn't move it over an extra 1. We didn't move it 1 over to the left. We didn't move it 3 over. We move it 2. 100 is that second decimal spot to the right of the decimal point. That's why we move it to twice, obviously. So we just want to move it over to the left, and that becomes 0.6. So both of them are equivalent. They are the same. Even if one looks bigger, you could even rotate one of the images to see that they are the same numbers, to see that both squares have the equal portion of it shaded. So let's look at some context problems with sequences. So I have given some answers. We'll go over the answers, and I have some problems that you can try on your own that you can pause the video and I'll explain that then. So let's just look at this one. Maybe 0.3, 0.6, 0.9, 3 blanks. And we want to know what the next 3 terms are. Well, we need to figure out what the common ratio is, and I talked about that in my other video, or we can just do even so simplified as we can see how much we're increasing from each decimal point. And how much we increase from each decimal is 0.3, right? From 0.3 to 0.6, we increase by 0.3. From 0.6 to 0.9, we increase by 0.3. So we just want to do that for the next 3, right? I suggest, I can do this mental math, and you will be able to also, if you can't already soon. The more you use them, the more you get comfortable with them, the more you'll be able just to do it in your head. If this is your first time looking at decimals, if you're still a beginner with decimals, please get a paper and pencil, write down that 0.9, and do 0.9 plus 0.3 line, and then add them, move the 1 over, carry down the 2, and 0 plus 1 is just 1, so you have 1.2 is the next one, 1.5, 1.8. You can see the pattern. Obviously we just add 0.3 to each number. If you need to do it for the 1.5 and the 1.8, please do that. But some of you will just be able just to see 1.2, 1.5, 1.8. And you can even visually see that is, if we multiply each number by 10, it'd be the same thing: 3, 6, 9, 12, 15, 18. Many of you can count like that, just increasing by 3. And that's what we're doing. We're just increasing by 3/10. We're increasing by, a fractional parts. So now let's try it on your own. So this is a time where if you're watching the video, please pause the video and try it on your own, right? What are the steps that you need? First you need to see how much it's, increasing by, right? Then if it's an easy increase, maybe you can just do it right there. Just add find those next 3 terms. Maybe you can even multiply each number by 10, right? Make it 2, 4, 6 and find out what the next 3 would be. Or if you're having a challenge with it, subtract the second term from the first term, or the third term from the second term, right? This is either addition or subtraction, and see the difference, and then that will get you the difference, and just add it. And if you need to write it down, right? We have 0.6, 0.6 minus 0.4 equals what, right? And we need that next, we need that number, and then that number, whatever it is, added to 0.6. So again, pause the video because I'm about to say the answer. So the answer is 0.8, 1.0, and 1.2. Now, how did I get that, right? You can either see it as 2, 4, 6, 8, 10, 12, right? I'm just giving you the even numbers. We're increasing by 2. Or you can see that the difference between 0.2 and 0.4 is 0.2. If you want to just double check that, the difference between 0.6 and 0.4 is 0.2. And that's what we're doing. We're adding 0.6 plus 0.2 equals 0.8. Do that with the next term. 0.8 plus 0.2 equals 1. 1 plus 0.2 equals 1.1. And what I would do for the 1 and the plus 0.2, just so you don't get confused with the decimal places, where everything aligns properly, because that is very, very important. What I would do, just starting off, you do not have to do this if you can understand them properly. But what I would do 1.0 plus 0.2 equals 1.2, right? Just understanding those decimals where the tenths align and when then the ones align, so it's perfectly aligned. And let's just check our answer, right? It's there, just to see again, right, how we increase by those even numbers. Right, what comes next in the sequence, right? Another problem. I gave you the answer here, except, right, what we're doing is we're subtracting 0.4 to each number. And how can I see that? Well, I can do 3.0 minus 2.6, and that equals 0.4. Because how am I doing that, right? It's the same as doing 30 minus 26, really, equaling 4. The same concept, right? We can cross out that 3, make it a 2, cross out that 0, make it a 10. 10 minus 6 is 4. 2 minus 2 is 0. So we have 0.4, right? We just want to drop that decimal point down. Same thing can go for the 2.6 and the 2.2. 6 minus 2 is 4. 2 minus 2 is 0. So the answer is just 0.4, right? Not the answer. I mean the, how we can get the next 3 terms. 2.2 minus 0.4 equals, 2 becomes a 1. The 10th 2 becomes a 12. That becomes 8. And the ones would just become 1, so it's 1.8. 0.4 from that is just 1.4, and then 1.4 minus 0.4, you can see it's just 1. So let's try it on your own. This would be the time to pause your video again. If you want to try it on your own, if you're still having trouble, that's totally okay. I'll explain it. Okay, so what's the answer? The answer is 3.5, 3.0, or 3, 2.5. Now, how did I get that? We have to find what we're subtracting by. The answer to that is 0.5. You can maybe just see that very easily, right? 5.0, 4.5, 4.0, 3.5, 3.0, 2.5. You can see that trend, right? You can see that pattern. Or you can just do it the mathematical way, right? 5.0 minus 4.5 is, that 5 becomes a 4 and the 0 becomes a 10. So it's 10 minus 5, and that's 5. And 4 minus 4 is 0. So it's 0.5. You could even check that again. 4.5 minus 4.0, you can obviously, will be 0.5 if you just wanted that double check, if you just wanted confirmation, maybe you did something wrong. And the next 3 from that, right, with 4.5 minus 0.5, the 4 becomes a 3, the 0 becomes a 10, 10 minus 5 is 5. Carry the 3 down, carry the decimal point down, that's 3.5, minus, to keep going on, 3.5 minus 0.5, it's just 3, 2.5, 2.0, 3.0 minus 0.5, 3 becomes a 2, 10, 0 becomes a 10, 10 minus 5 is 5. Carry down the 2, carry down the decimal point, that becomes 2.5. So those are the next three terms, right? That whole sequence is, 5.4, 4, 3.4, 3, 2.5. What comes next in the sequence? Right, another one. This one is now the next portions of these sequences are going to be a lot more complex, right? This is more advanced. I don't expect really anyone to get this right off the bat, especially if this is your first time seeing decimals. This is honestly more for the people who have seen decimals and need to go a step further. What we're doing here, you can see, you might want to say like, right, maybe this is an addition or a subtraction, right? If I obviously didn't give you the answer, you didn't see what's being multiplied by. But if I'm not giving you that answer, right, you might want to do 1.2 minus 0.4, right? 1 becomes a 0, the 2 becomes a 12. 12 minus 4 is 8. Carry down the 0 and the decimal point, so it's 0.8. And you might think that's it. You might think we're adding by 0.8. But if you can see, if we did 1.2 plus 0.8, that's 2. And that's obviously not 3.6. So what does that mean? Well, it's not addition, and we know that we're increasing. So your first thought after that should then be multiplication. And that's what it is. To get from 0.4 to 1.2, we multiply by 3, and 1.2 to 3.6, we multiply by 3. Right, and maybe the tens, right, because it's power of 10, if you want to move the decimal point over to the right for everything and see that, we're going from 4, 12, 36. Excuse me. Many of you can see, right, we're just multiplying by 3. It's very simple that way, just to multiply by 3, and looking at, 4, 12, 36. So the next ones are obviously we just multiply 3.6 by 3, 10 which is 10.8, right? The 1 goes to the top, 8 there, 3 times 3 is 9. Add the 1, 10.8. Say now we have to do 10.8 multiplied by 3. Move the 2 up, bring the 4 down. Bring the 2 down, then multiply 3 by 1, that's 3, so 32.4, and then 32.4 multiplied by 3 is 97.2. Now, those numbers do get complex. Those numbers do get big quickly. If you do need to use a calculator, please use a calculator, especially with that 32.4 to 97.2 can be a little bit hard. But what I will say is that you can do it, right? It's the same thing, multiplying smaller numbers, same concepts, just, more steps. And that's what we're doing, right? And just to double check that we're multiplying by 3, right? We can also divide. We can go right, we can go backwards. If you want to set up a problem, by the way, if you wanted to set up a problem, it'd be 1.2x equals 3.6, right? So if we have 1.2x equals 3.6, that means that we have to divide the 1.2 on each side. So x equals 3.6 over 1.2, and that equals 3, right? Or we can go the other way, right? If we want to see, 3.6, how we get 3.6 to 1.2, we divide the 3.6, it's 1/3. So one third going to the left is multiplying by 3 to the right. So let's try it on your own. And I'll give you a hint right now that, it's obviously a multiplication problem. I don't want to say obviously. I'm saying obviously because the one before was a multiplication problem. So I'm giving you another multiplication problem. And then we will move on to division. Right. And I do like to categorize these two, addition, subtraction is one group, and then another group being multiplication and division, because multiplication and division is much, much harder to not only visualize and mentally do, but mathematically do as well, and to just, visually being able to see it. So pause the video now if you'd like to try it on your own. So the answer is 1.6, 3.2, 6.4. So how do I get that, right? I say I multiply by 2. How do I know I multiply by 2, though, right? Stepping equation, I think, is the easiest way of doing this, right? 0.2x equals 0.4. If I divide 0.2 on each side, I have 0.4, divide by 0.2 equaling x. And 0.4 over 0.2 is just 2, right? An easy way to visualize 0.4 over 0.2 equaling 2 is just multiplying the top and bottom by 10. So you have 4 over 2, and 4 over 2 equals 2. The same would go, right? You can see, do the same with 0.8 and 0.4. And, if you want to just back solve, you'll hear people say, if you just want to see it that way, you can see, 0.8 to 0.4, it's a half. Each number is a half. Maybe that's hard to tell. So you can see 0.4, though, a half of 0.4 is 0.2. So, if you go a half to the left, that means you multiply 2 to the right. So multiplying 2 by 0.8. Right, you can even say, 8 times 2 is 16. Then we can just put the decimal point back over to the left one, and that's 1.6. Same can go, if it's still hard, we can do 16 multiplied by 2, it's 32. 32 multiplied by 2 is 64. And just put the decimal point 1 over to the left, making it 3.2 and 6.4. That way, you can get in that decimal form. Or, if you're keeping it in the decimal form is also, probably the best way, especially for beginners. Do 1.6 multiplied by 2, and just make sure you carry the decimal point down where it should go. It is extremely important that you do that. And this is a simple multiplication decimal problem, and because there's only one decimal point there, and it's in the 10th spot, with that 1/10 number, it'll end in the 10th spot with that 1/10 number. When you multiply two decimals, that becomes a little bit more tricky. And I can explain that later if you have a question on that. But I do not believe I have given you any of those multiplication problems where you would have to use that identity. So what comes next, right? This is dividing now. That last hard one, right? The first one was multiplication, now division. We have 40, 20, 10. We want to know the next three. The next three I obviously say is 5, 2.5, and 1.25. How do I get those numbers? Well, first we have to identify, is it addition, subtraction, multiplication, or division? Well, we see that we're decreasing. So your initial thought should either be subtraction or division. So we can do 40 minus 20, and that's 20. So then technically, if it was subtraction, our next one should be 0, not 10. Should go 40, 20, 0. So then we have to wipe away subtraction. Now that you know subtraction is not the correct way to solve this equation or the sequence, right? We go to division. And for division, we have to divide basically the 40 over 20 is 2. So, right, that you can either do 40 over 20 and see that it's 2, and that, going now to the right, it's either you have to multiply by half going to the right, or multiply by 2 going to the left. Or you can just do that second term divide by that first term. Sort of like the same concept for multiplication. Nothing has changed there, and just except this is dividing. And 20 over 40 is 1/2. Just to double check, that's division. 10 over 20 is 1/2. Right? We're still not even in decimals yet, right? 10 divided by 1/2. 10 multiplied by 1/2 is 5. 5 multiplied by 1/2 is 2.5, right? Now we get into those decimals, right? What's half of 5? 2.5. Now you can maybe you just know that off the top of your head, right? And nothing new has happened there. Or you have to, get your pencil paper, do how many times does 2 go into 5? 2. So then, but we're 1 left over, you have that 10 now. So you put the decimal point there, and then 2 goes into 10 5 times. So that's how you get the 2.5. Now that next one is 1.25. Well, how do we get there? Same thing. We can just divide that 2.5 by 2, and we have 1 goes into 2 ones, decimal point, 1 decimal point, very important. Now 2 goes into 5. How many times? 2. And then we need to then add a 0, right? Because technically that 2.5 is the same as saying, 2.50, 2.500000, so on. It's the same number, right? You can just knock off those zeros. But just, as a holder place, we can put that 0 there and, carry the 1 over. So 2 goes into 10 5 times. So our answer would be 1.25. And you can see the similarities between 2.5 and 1.25. So now try it on your own, right? Again, this is going to be the time to pause the video. I do apologize. There should be a comma in between 250 and 50. I did forget that. I am sorry about that. But there should be a comma in between 250 and 50. Okay, so let's solve this problem. The answer is 2.4.08. Now, how do we get that, right? Well, we get that by doing by division. And right, your first thought should have been subtraction. Maybe it wasn't, because we just did division and you just went straight to division. That's fine. But really, you should have thought subtraction first. And 250 subtracted by 50 is 200. So your next thought should have been, well, 50 subtracted by 200 is negative 150. But the next one's 10. You see that can't be correct. So then your second thought, right, that this thought now is that it is division, right? And that is the case. 250 multiplied by either, you can see it by multiplied by a fraction will equal 50, right? Or just do 50 over 250 equaling 1/2. Right? And that's what we're doing. We're dividing by that 5, right? 250 divided by 5 is 50. 50 divided by 5 is 10. Now 10 divided by 5 is 2. Now that it's still not decimals. Now we get into the decimals, going with the last 2. 2 divided by 5 is 0.4, and then 0.4 divided by 5 is 0.08. And the 0.4 is probably easier to understand than that 0.08. what we're doing is, 5 divided by 2.0. 5 doesn't go into 2, so 0 decimal point. How many times does 5 go into 24? So zero point 0.4. Now, the next one is 0.08. Now, how do we get that, right? Divide by 5. Same thing as we've always been doing for this problem, right? 5 divided by 0.4. Well, 5 doesn't go into 0.4, so it becomes 0.0. Now, we can put another 0 in the hundredth place. So now it's, how many times does 5 go into 40? Because we have that extra 0, and that's 8. So 0.08 is that last term. I hope that makes sense. That last two, especially that last one, can be very confusing. You may not get that if you did not use that paper and pencil, like I've been saying. That transition from dividing 0.4 by 5 to have that equaling 0.08 is something that I would suggest using that paper and pencil for visually seeing how to do that. Maybe you can even multiply by 10, so it's less decimals in your head, but it does get complex when you do get further and further away from that decimal point. So that's why you have to be comfortable using decimals. So sort of we can move away from that complex portion of sequences with decimals. And this is just a number line. 6.1 is on the left, 6.2 is on the right. Where should 6.178 go? Now, right? And we're going to be talking about rounding soon and things like that. But where should 6.178 go? Now, it should go, okay, well, first of all, let's just analyze that decimal, right? Because we know we're in this, we have 6. So basically that number line is saying where should 0.1, we have 0.1 to 0.2 of a number of 0.178, right? Well, now what we can see is that from 0.1 is the same, right? It's saying 0.100. And 0.2 is the same as saying 0.200. So there's two, right? And if we just want to visually see that, right? 100 over 1,000 and 200 over 1,000. And that becomes very simple. And the reason why I went out 3 was because we have 3 numbers to the right of the decimal, that 178. So now we're just placing 100. Now we have a number line 100 to 200 with the number 178. And that number, I would say, would go somewhere right here. I'm not sure if you can see my decimal point. I mean, not decimal point, my mouse is hovering around the range between, if we took the halfway mark and we went to the right of that and split that in half again, a little more to the right is where my arrow is. And that's exactly where it is. There's a link at the bottom called Fun Games. I found this website. It is such a good website, one of the best websites I've found for kids. It's so many games about decimals, about number lines, trying it on your own, multiplication, division, subtraction, addition, other things that we'll go into about like estimation and rounding. Really fun games, very interactive, easy to maneuver, easy to learn how to play the games, and very fun. So highly suggest just clicking on that link and exploring that website for sure. So another thing connected to decimals is understanding measurements. And there's a link at the top also that if you just want to get a little more hands-on learning with that ruler and decimal, please do so. Um, but this is a ruler, right? And I gave you some decimal points, right? And you're wondering how maybe you got to those decimal points. Well, in between each number, there are 10 ticks, is what I'll call them. 10 ticks, right? 10 dashes, 10 lines. So each number represents a fraction of it, right? Let's say we go 3 out. We have 0.3, 8. We count 8 times. 1, 2, 3, 4, 5, 6, 7, 8 is how we get that 0.8. Now we hit 1. So now, but we're still counting by ones, right? 1, 2, 3, 4, 5. It's just important that in the 1 spot, we have that 1. And in the 10th spot of the decimal, we have the 5. We can count 2 away from the 4. We can even go backwards. We can start at 4, go out 3, and subtract 0.3 from 4 and get 3.7. But you can see visually, maybe if the block idea did not work, maybe this ruler method does work. Maybe you're comfortable with rulers. Maybe you haven't used rulers at all. Either way, though, this is just another way of looking at decimals, understanding the ticks, the lines. If we want to even go more complex, right? In between each dash, we could put 10 more dashes, right? And that would be then the 100th spot, right? Let's say we need to find, 2.57, right? That's obviously in between the 2.5 and the 2.6. But then we need to count 7 dashes in between that 5 and 6 dash mark. So that does get a little bit more complex. That's why I didn't want to use something like that complex for the 100th when looking at it. But when looking at it for the 10th spot and the 1 spot, it definitely does help and definitely does come in handy. I hope this does make sense, that you do see the fact that the decimals are just a fractional part of that whole number. So let's just try some problems, right? I did the first one with you. The first one is 0.2, right? This number line is from 0 to 2. In the middle is 1. So all we're doing is counting the ticks. 0, 0.1, 0.2. So A is 0.2. Now just one more tick is 0.3. So B is 0.3. Now we have a little ways to go to C. 0.4, 0.5, 0.6 is C. 0.7 D. 0.8 E. 0.9, and then we hit 1 at F. And now we start the process all over again, except we now start at 1, right? We'll do 1.1, 1.2, 1.3, 1.4 instead of doing 0.4. 0.1, 0.2, 0.3, 0.4. So, right, let's start. 1.1 is G. 1.2, 1.3 is F. H, excuse me. 1.3 is H. 1.4 is I. 1.5. 1.6 is J. 1.7 is K. 1.8. 1.9 is then L. And then we have hit 2. So let's try again, right? But a different number line, right? We start at 6 and we're going to 8. So let's just, I'll give you that, right? M is 6. Now let's keep going, right? N, 6.1, 6.2, 6.3 is O, 6.4 is P, 6.5, 6.6, 6.7 is Q, 6.8, 6.9 is R, 7, 7.1 is S, 7.2 is T, 7.3, 7.4, 7.5 is U, 7.6, 7.7, 7.8 is V, 7.9 is W, and 8 is X. So now let's do a little fill in the blank. Write the missing number. Again, you can try this on your own before I do it with you. I will definitely show you how to do this. So, right, it's a little hard to see that number on the far left, but that second number is 7.7 and 10.7. So what's your first thought? Well, we're getting higher, so that first thought should be addition. That doesn't work, multiplication, right? But really, addition will work fine here. 7.7 to 10.4 is just a 0.7 increase. Excuse me, 2.7 increase. 2.7. I should have not rushed that. That was my fault, right? We can do the math. 10.7 minus 7.7. That 10 becomes a 9. That 4 becomes a 14. 17 minus 4 is. Oh, excuse me. My bad. I did that wrong. My bad. It should be 10 becomes the 9. The 4 becomes the 14. That's where my mistake. I said 17. It should have been 14. That I said 14 minus 7 is 7. 9 minus 7 is 2. So that means 2.7 is the increase. So now we have to add. We can either add 2.7 from 10.4 or 15.8 minus 2.4. 2.7. Either way, it'll give you the same answer, right? 10.4 plus 2.7 is 13.1. The next one is we want just one tick in between 10 and 11. So it's basically saying what's the middle number between 10 and 11? And the answer to that is 10.5, right? That middle number in between 10 and 11 is 10.5, right? That halfway point. And for the final one, again, I'll give you the hint. That's obviously addition. How do we want to get from 0.1 to blank to 2.9 to 4.3 to 5.7? Well, let's just subtract 4.3 from 2.9 and get 1.4. How did I get that 1.4, right? We did 4.3 minus 2.9. 4 becomes a 3. 3 becomes 13. 13 minus 9 is 4. 3 minus 2 is 1. So then the answer, because it's a 1.4 difference and we start at 0.1, we have to add 1.4 to 0.1, and that's 1.5. So let's try some mental problems. I've hoped. I want to say that you're guaranteed to do these mental. I'm being very optimistic in that regard, but I hope that you can try and just take a stab at doing these mentally. So the first one, what is half of 5? Well, if you're looking earlier, half of 5, it says 2.5, right? We're doing 5 divided by 2. What is double of 0.34? Multiply by 2. 4 times 2 is 8. 3 times 2 is 6. Ahead of myself. So the answer there would be 0.68. What's triple now of 1.6? We have to multiply by 3. So 6 times 3 is 18. Bring the 1 over, drop the 8 down. 3 times 1 is 3, plus the 1, so that becomes 0.48. Now a little subtraction, 4.5 minus 1.2. That's a little confusing. You can, and you're not doing this mentally. I would suggest putting the 4.5 over the 1.2 and subtracting it that way. So the ones and the tenth spot and the decimal points do line up. That answer is 3.3 because 5 minus 2 is 3 and 4 minus 1 is 3. Now we have a little more complex one. Maybe you do have to write this one down. You can maybe just look at the 10th spot or the 1 spot first, right? Let's say we want to look, I'd look at the 10th spot just in case it goes over 10 and we have to add 1 to the ones. Right, 10th spot, we have 1, 3, 2, so that becomes 6. And then we have ones becoming the 1 spot where it's 1, 2, 5, so that's 8. So the answer then when we combine those two is 8.6. So let's try another set of mental ones, very similar in numbers to the other one. If you want to pause the video now, try on your own, please do so. But I will continue. So twice of what is twice of 2.4? So multiply 2.4 by 2, and that is 4 times 2 and 2 times 2. So that becomes 4.8. What is double of 0.54? Now we have to, we'll be becoming in the whole number range, the whole number, because, right, 4 times 2 is 8. So that goes in the 100th spot, but 5 times 2 is 10. So so 1 now goes in the 1 spot and 0 goes into the 10th spot. So the answer is now 1.08. 5 times 1.2 is 6. Or line that up. 5.1 times 2. 2 times 5 is 1. 5 times 1 is 5 plus 1, so 6, so 6.0 or 6, either number fine, right? We don't need that decimal with the 0. I just included it just in case, to visually, just to see it better. What's 9 divided by 1.5? Hint, whole number, right? That number is 6. And then 25 divided by 2 is 12.5, right? We can do that 2 going into the 2, 1, 2 going into 5 twice with the 1, and carry that 1 over to the 0 and just divide by 2, and that 10 divided by 2 is 5. Obviously same as with the 4, 1.5 into 9, have those zeros. That is a little more complex, and what you need to do, you can sort of just, play around, guess with it, because I do say it's mental problems. You can be like, maybe 1.5 multiplied by 5 is 7.5, or maybe 1.5 multiplied by 7 is 10.5, and maybe you try 6 and you get lucky and get 9. Either way, divide, multiply, whatever you want to do, either way it can work mentally. So partitioning, I talked about this earlier. It's good visually just to go back to it, just to take a little time out and definitely spend some time looking at it. So obviously, what does that partitioning look like? All right, we have that number 13.5, and I did tell you, right, that tens spot, the 1 spot, decimal point, 10th, hundredths. I'm telling you, most important part in this presentation, right? Understanding that, and then partitioning it, right? You can see 0.6 plus 0.02 plus 0.005, right? That partitioning, right? Going back to the blocks, looking, seeing that adding those up will equal that 0.625. So partitioning examples. 10 plus 0.5 plus 0.06, right? Whole number, 10 spot. hundredth spot, right? When we have the hundredth, we need a 0 in that 10th spot. 5.91. 5 plus 0.9 plus 0.1, right? Whole number plus 10th spot plus hundredth spot, right? With the 10th spot being a 0. Now, I did make a mistake. My bad. This should be 0.1 instead of 1, right? 7.1 is 7 plus the 10th spot, which is 0.1. My apologies. Then we have the number 100, right? Whole number plus 10th spot, 0.5 plus 10th spot, 100th spot is 0.06. Then so on and so on, right? We can do 45.543. Now that becomes then the 1,000 spot we'll need at the very end, right? With the 0.003. Then 100th spot, 0.04, 0.5, then 45. You can go really either way, right? We can start with the decimal. We can start with the 100th spot, 0.01, going to 10th spot, 0.2, whole number, 309, right? 1,000 spot, 0.005. We need those 2 zeros in place of the 10th and the 100th spot. Then we have 0.08, then 1, right? And there's nothing in that 10th spot. Keep an eye on that one. So try on your own. This is when you can pause the video. I might keep going, right? You can see, right? Either way we want to go, right? Except, that first one, there's nothing in the 100th spot. So we can just skip that, and you can see that there. I don't have a number for the 10ths. For the second one, there's nothing, there's a 0 in place for the 1,000th place. So you don't need a number for that, For the third one, there's nothing for the 10th or the 100th, so you don't need numbers for that either. But for the next 4, 5, 6, and 7, it does look like you will need numbers, except for 6 for the 10th spot. But for all of the other places, you will need numbers, right? Looking at 4 and 5, right? We have the whole number, the decimal point starting off with now the 10th spot, 1, 100th spot being 4, so 0.04, and then 1,000 spot being 0.005. Same for 5. 17 decimal point starts. Now we have 10th spot 0.6, 100th spot 0.05, 1,000 spot 0.007. For 6, we don't need anything for the 10th spot, right? We can see that, just add the 0.09, 0.0002, and for the last one, same idea, right? 0.7, 0.08, 0.009 is obviously the same as 4.789. Oh, excuse me. The link at the top, Tons of Fun Decimal Games. It's a link. Tons and tons of fun decimal fraction percentage games. Highly, highly, highly recommend checking it out. Really fun. Great way, if it's gotta spend some time inside. If it's raining out, go check it out. Definitely highly suggest looking at that website. Just a little joke, right? Forget the decimal point that says $100. Obviously it meant to say $1, but that's why the decimal point is so important. Now let's talk about rounding decimals. Rounding decimals are a way to estimate a number's value to make it simpler. You've probably heard of rounding, right? Rounding 15 to 20 or 99 to 100 or, so on. But just in case you are unfamiliar with rounding, just want to learn a little bit more about rounding, I can show you that for sure. But this is going to be how to round numbers. Just maybe if you don't know how to round numbers, decide which is the last digit to keep, right? That'll be in the directions. Round down. If the next digit is less than 5, keep it the same. Round up. If the next digit is greater than 5, increase the digit by 1. If the number is 5 the majority of the time, round it up. Sometimes you'll see special scenarios where they say even if it's 5, round down, but conventionally and traditionally 5 is rounding up. So rounding decimals, right? Rounding to the 10th spot, leave one number after the decimal. Rounding to the 100th spot, leave 2 numbers after the decimal. Rounding to the 1,000th spot, leave 3 numbers after the decimal, and so on, right? This is how, you can see the pattern that way. Examples, right? This is me rounding to the 10th spot. We don't care about the whole number unless the 10th spot goes from 9 to 10, and then it will. But if not, then we don't have to look at that whole number. Surrounding the 10th, well, I'm just going to look at the decimal points, right? 0.56, right? Basically 56, round it to 6, right? Because that 6 is greater than 5, so round up. So change that next number to 6. 0.512, we do not need to look at the 2 because we want to round that 5 number, either keep it the same or round it up. So we will look at just the 51, and that 2 is a distractor, and 1 is less than 5, so we keep it at 5. 0.678 is another distractor with the 8. Right? We don't need that 8. We just want to look at the 6 and the 7. 7's greater than 5, so we round up. Look at so that becomes 0.7. 0.564. We don't need to look at the 4. That's a distractor. So we just look at the 56, and the 56 can just become 6, right? That actually is very similar to 10.56, the first one, except, right, we had that distractor 4. We don't need to look at that 4. We're not concerned about that, right? We need the 1,000 spot to round for the 10,000 spot. For the 0.09, we need to then round that 9 to a 0, round that 9 up so that the 0 becomes a 1, and so 0 becomes 1, and we don't need anything for that place now. We can keep a 0 there and leave it 0.10, but we do not need a 0 in that spot. 5.07 is the next one. 5.07 becomes the 0.07 becomes 0.1 because the 7 is greater than 5. So 5 rounds up. 1.001, excuse me, becomes 1.0 because of rounding. We don't need to round it at all. So we cancel out the 1,000 spot, and we can cancel out all the other numbers. Right, 1.0. I left that there in the 10th spot, but we really don't need it, and we can just keep it at 1. If you had that also, that'd be acceptable. 10.91, right? That 0 and 1 are distractors. Do not look at them. Just look at that 91, that 0.91. 1 is less than 5, so we don't do anything, and it's just 10.9. Right. We go for the 100th. Same idea, just one step further, right? Now we do need to look at that thousandth spot to then round for the 100th spot, right? So let's look at the first one. 6 is greater than 5. No, by the way, you don't have to, I'm not going to say the whole number, right? We can just fill in the digits where needed. But looking at that 6 to round for the 100th spot, 56, right, is just that rounded becomes, right, 6 is greater than 5, so we round up, that becomes 6. We look at the 9 and the 0, don't even look at the 1, throw the 1 away. Oh, excuse me. We just want to look at the 2 and the 9, throw the 0 and 1 away. So that becomes just 3. We have 7 and 3. 3 is less than 5. Don't do anything, just leave the 7. We have 1 and 1. 1 is less than 5. Leave it the same. This one's now a little bit different, right? We have 31.199. We want to round it to the 100th spot, but it goes over, and so we have to then carry it to the 10th spot and make that 2 and make the 100th spot 0. Same concept happens for 6, right? When rounded, it goes over to 10, so that means the 10th spot has that 9. The 100th spot becomes it doesn't change because 1 is less than 5, and for 0.666, that becomes 0.67 because 6 is greater than 5. The 1,000th spot, we want to then look at the thousandths and 10,000ths. This is the farthest we'll round, because after this you should get the idea. We compare the 1 and the 2. 2 is less than 5. Keep the 1 the same. Compare the 0 and 1. 1 is less than 5, so keep it the same. 6 and 7. 7 is greater than 5, so we make 6 a 7. 0 and 9. 9 is greater than 5, so we make it a 1. We have 7 and 7. 7 is greater than 5, so that becomes an 8. We have 2 and 1. 1 is less than 5, so that becomes, so we leave 2 the same. 3 and, 6 and 6. 6 is greater than 5, so that the other 6 becomes a 7. And lastly, 0 and 1, and that becomes a 0. And what you can see that I did for all of them, I just took the 100th spot, 1,000th spot. Just looked at those two numbers, right? 100th spot, 1,000th spot when rounding. Oh, excuse me. I took the 1,000th spot and 10,000th spot. My bad. The 1,000th spot, 10,000th spot. One to the right of the decimal. One to the right of the place we're rounding, because we're rounding to the thousands, that we want to look at the 10,000ths also. That 10,000th number is greater than 5. We rounded that 1,000th number up 1. If it wasn't, we kept it the same. So try all on your own. If you want to pause the video right now, please pause the video. I'll keep going. You can see the answers on the right, right? Just look at the 9 and the 1. 9, 1 is obviously less than 5, so that's 9. 7, 7. 7 is greater than 5, so 7 becomes an 8. 7, 6. 6 is greater than 5, so that becomes an 8. 1, 1. 1 is less than 5, so that becomes a 1. No change, right? 4, 1. 1's less than 5, nothing changes. 7, 2. 2 is less than 5, nothing changes. 9, 5. um, that becomes 41.0. That's special, right? We have to now look at the one spot because when we round the 10th spot, we're rounding the 100th spot, that becomes 0, and now we got to carry that 1 to the 1 spot. So the answer to that one is now 41, a little bit trickier than the others. And then we have that 55, and that becomes just 0.6. Right now we have the round the hundredths. Um, try on your own. I'm sorry if you couldn't pause in time. Um, right, just look at the last two numbers and round. That's what we've been doing the same time. Um, the key ones I want to point out is number 2. Look how we had to change 56.999 to 57 because we have to carry that 1 over until it has a spot to go into. And you can see 5 and 6, two different numbers you can see, but they round to the same number, right? Because right, that we need a spot to find for that 1. We keep going to the left until we can find one. And then the 1,000 spot. Key ones definitely are really just paying attention to the decimal, paying attention to which one you're rounding. The numbers do get long and complex. Don't be scared. You guys got this. You can do it. I'm just gonna keep going. Just because I'm confident that you guys understand this rounding, especially because I'm sure you guys have done it. The only difference with this rounding is now there's a decimal point. Really, is frankly all there is. And now we want to compare numbers. So comparing, right, smallest to biggest. Well, what is that, right? The smallest number is going to be the number that is farthest to the right. Okay, so what does that mean is that we compare the 10 spot, right? Well, all of them have zeros for the 10 spot, so we don't have to do anything for that. Now we look at the 100 spot, right? Well, as we want then to find one that has 0, right? Or the lowest number possible, and the only one that has that is the 0.008. So that's the smallest. Now we want just to look for the smallest number. There's 2 that have 1, 0.01 and 0.018. Either number, you may be thinking, are they, they're not equal, but which is smaller? Well, smaller one is the 0.01 because there's nothing in the 1,000 spot, right? It's really 0.010, and that has an 8. So that's slightly bigger, the 0.018 than the 0.01. And same concept for the 0.08, the 0.081, which is bigger, the 0.081 because of that number in the 1,000 spot. We look at number 2, right? The whole number all the same. So we look at the 10th spot. We have a 3, 5, 0, 5, 4. Well, that 0 is obviously the smallest. Then we can just plop the 3 is the next smallest. 4 next smallest. And then we have 2 that are 5. Obviously, right, like what I've been saying, that's really 4.50 instead of, and that's 4.53. 5.53 is obviously bigger than 50, so it's 4.5 and 4.53. Right, this one has different whole numbers, so keep an eye on that. So we only have to compare now. Let's start with the 11s. That's 11.01. It's smaller, right? Look at the 10s. Smallest one there is 0. The next one is now 1. Right? So those 11s go there. Same exact concept for the 12s. Find one that has 0. 2 of them do. So you know that the 12.1 has to be the greatest, or 12.101, my bad, has to be the greatest. And then we compare the 12.01 and 12.09.
9 is greater than 1, so 9, the 12.09 is greater. Same exact thing now, but just bigger to biggest to smallest, right? We can look at, whole number first, 6 is greatest, then we go into the fives, go into the one spot, except we want the biggest one now. I mean, not one spot, the 10th spot, excuse me, of the decimal, 7 there, greatest. Then we have the 5, greatest, 1, greatest, 0, greatest, right there, just plop. Now, just put in those numbers. Now you look at 2, 2 can be definitely a little more intimidating, but, start with the 10th spot, right, because the whole number is the same. Only 1 has a number that isn't 0, so 33.1 is greatest. Now we look into the 100th spot. Well, one of them does not have a number in the 100th spot. It's 33.001 as a 0 there. So that's the smallest. So now we're left with 3 numbers. And one of them is 2 or 9 and one's a 1. So that 1 has to be the smallest, So now we're comparing 0.091 and 0.099, and obviously with the of just decimals, and the 9 is greater than the 1. Looking at the last one, whole numbers first, 8.5, 8.09, 8.001, right? There's nothing you even had compare it in the 10th, 100th, thousands, because they all had different numbers. And then 7.88 is greater than 7.099 because 8 is greater than 0, right? So try it on your own. Pause the video now. I am going to keep going. The answer to the first one, right? Compare. You see that the 10th spot is the same for all. So we gotta go to the hundredths. Well, 18.9 has 0, so that's the smallest. And then 18.909 and 18.901 are the second, or the other two that have zeros there, but they have numbers in the thousands. So compare the 9 and the 1. 1 is smaller than 9, so place those two numbers. Then we're looking at 18.99 and 18.95. The 95 is smaller than the 99. Looking at the second one, right, compare the 43s with the 42s. 43 is obviously the greatest, so we can just place that there at the right-hand side. Now we're looking at the next, right? Just look at the 10th spot. Only 42.09 has a 0 in the 10th spot, so place that. 41.1 is the next smallest with a 1 in the 10th spot. 42.5 has the 10th spot. Oh, excuse me, there's a 43.09, and that's obviously smaller than 43.1 because 1 is greater than 0. My bad, I did not see that other 43 there. I apologize. For the next one, a little bit more complex. What I would do, right? We see compare the 71.555, 71.565. 71.555 is less than 71.565. Then we have compare the 0.656 and the 0.665, because, right, 0.666 is 1 greater than 0.665, but also 656 is less than 665. And biggest to smallest, try on your own. The answer is look at the whole number, 12.1 and then 12.090 are the two greater of the whole numbers. Then we have 11.999, which is almost 12, excuse me. Then 11.09 is greater than 11.09 because there's nothing in the 1,000 spot for the 11.09. We look at the second one and the third one, right? Same exact concepts, just placing them, seeing 1.9, 1.1, 1.00, 1.009, 1.001. As you keep doing it, you'll get more and more comfortable and become more and more simpler. And then 5, 4.991, 4.901, 4.555, and 4.321. Just quickly into negative decimals. Negative decimals are the same concept as positive decimals, but backwards, right? You can see that the number line for decimals just goes backwards. Right, how to compare negative decimals. We're looking for the number that is closest to 0. Normally for positive numbers, we want the highest number. The same is true for negatives, but remember, the more negative a number is, the less the number actually is. So example, which is greatest? Negative 0.5 versus negative 0.75. Answer. You may think initially it's negative 0.75 because 0.75 is greater than 0.5. However, the greater number is negative 0.5 because it is closer to 0. Rounding negative decimals. Remember, it's the same as positive numbers, positive decimals. Same concept. But we can do a quick review, right? Tenths, hundredths, thousandths. Negative 1.09 is negative 1.1. Negative 0.0995 to the hundredth, negative 0.10, and negative 0.7833 becomes negative 0.783, right? Try it on your own, pause the video. I know you guys are probably pros, that you're a pro at this already. You can see, you can look at the answers, right? The first ones, I did 3 in the tenths, 3 in the hundredths, 3 in the thousandths. Right, just again, if you want to want some more practice at rounding the smallest to the biggest numbers, there's some more practice here. Right, biggest to smallest now, even more practice dealing with these negative numbers. It's literally the same thing, just right. We have this negative sign, so it's the backwards thinking with positive numbers, right? You can even think of it, have that negative sign, but smallest to biggest when for positive. Do that and you'll get it for biggest to smallest to negative. Try it on your own. I do suggest looking at them, right? I can go over it quickly with you. Right, closest to 0 is what we are dealing with. We can look at something like number 3. We have closest, the smallest numbers. Right, we have 94.12 as being on the right, 94.13 on the left. Oh, my bad. And so on. And so you can see that it's negative 94.31, negative 94.3, negative 94.23, negative 94.13, negative 94.12. Biggest to smallest. I am confident that you guys understand this, and because I already explained it, I haven't been explaining it as much and just showing you the answers. But I do think that is enough justification to sort of just understanding it, maybe just looking at it. if you were able to ace the other ones, I'm confident you guys can do these also. These are a little bit mixed. If you want to do some review, um, right? When dealing with the smallest, we take those negative numbers, compare the negative ones, positive, negative, positive. Biggest we want positive, then negative, positive, then negative. Just checking your understanding with positive decimals. Decimals are fractional numbers that have a decimal point. Rounding decimal estimates or simplifies them, round up, round down. The highest number is the greater number. Check your understanding. The closer the number to zero is, the greater the number. Think of them backwards of positive numbers when comparing. Just a little bit about myself. My name is Aiden Silverman, and I am from Baltimore, Maryland. I'm a junior boys lad. I love to play sports, especially soccer and lacrosse. I hope you have enjoyed this video. These are some of the sites I was using. Um, and if I went too quickly at the end for you, please just check back at them.